welcome back. In the previous video, we actually added quite some functionality in our campaign smart contract. Alright, so by including the functionality of handling the campaign balance, the contribute button, and modifying the target and checking if the campaign is active or inactive. Alright, so now that we have handled quite some functionalities, so now the only thing that remains that needs to get added in the contract is how to create a request, that is creating a withdrawal request that would be created by the admin so that he can extract some specific amount in the name of some specific task. Alright, and then after creating the request, how the request would actually look like. Alright, so storing the request data and then handling whether the request is actually approved or not. And if it is approved by more than 50% approvers, then the campaign manager should also be able to finalize it. Alright, so now that we know on a high level that what we are supposed to do, so let's jump back to Remix and actually add this functionality in our campaign smart contract. So as you guys can recall, we have already created a struct request that will hold all the data specific to a single request. So it would hold the description, the value, the recipient of the request, whether or not the request has been finalized or not, that is it has been completed or not, so a boolean complete. Then we have an approval count, that is how many approvers have actually approved this request. And then we would also create a mapping to keep track how many approvals this specific request has received. So once we created a struct, we also created an array of this struct. So we actually created an array of type request, which was public, and then we named that variable as requests, which would hold all the requests for a specific campaign. So now that we have an array where we'll be storing our specific request, so now let's add a function to actually create one request. Alright, so I've created a new function known as create request just below my constructor. Alright, and this would be responsible for adding a new request to our requests array. So obviously this function would have some parameters, so it would be taking in the description which we'll store in memory because we don't want to store it in storage. And then we would need the value, that is how much amount that is going to be stored for the specific request, and the address of the recipient, that is once this request actually gets finalized, then to whose account that cryptocurrency is actually going to get transferred. Then obviously this function is actually going to be public so that it's accessible for the manager so that he can actually call this function. It would be restricted to the manager so that no other person could actually create a request in the campaign. And this function would also depend whether or not the campaign is active or not. So we would also add a modifier active campaign. So if the campaign is actually not active, the admin of the campaign cannot actually add a new request to that campaign. So now that we have actually described our function, let's go ahead and add some actual code that would be responsible for adding a new request into our requests array. And this function is actually going to be an excellent example of how to use memory and storage inside Solidity. Alright, so the first thing that we are actually going to write is that we are going to use our own data type, that was our struct request, and we are actually going to this time store it in storage. Alright, and then we are going to declare the variable as new request. So this is going to be a new struct. Alright, so this would have all the parameters of the struct that we just defined above. And then we would simply push this new variable inside of our requests array. Alright, without any data. So we have just initialized a new variable new request and it's a struct, so it has all the parameters, but we haven't defined one single parameter for it. And without even defining any of the parameters, we have simply pushed it inside the array. Alright, so it is a struct and it has all these properties, but they are not currently defined for it. Alright, so if you actually want to access the description of it, it would actually throw you an empty string. But in the next few lines, we are actually going to define what this request is going to look like. Alright, so all the parameters that we actually took in our function parameter, we are actually going to throw in inside this new request. Alright, so we are actually going to access the new request dot description and actually set it as description. That was our function parameter. Alright, and the same thing we are going to do for value and recipient. Alright, so now this request has been defined for a specific description, a specific cryptocurrency value, and a specific recipient address. So this whole operation was nothing different but adding an empty object to an array and then accessing that same object and afterwards defining those values for it. You could have also done it the other way around by defining the values beforehand and then pushing it into an array, but I handle it a little bit differently. So what I've done is that I have just initialized a new struct as new request, and instantly pushed it in my requests array. So request.push. Alright, so if you are not familiar with this line, that is equals to request.push, well, that's how you actually push a value inside an array while initializing it. Alright, so I've actually pushed new request while initializing inside our requests array and afterwards defined all the specific properties for it. And yes, you could have done it the other way around. But this actually saves us a lot of gas because we are performing less operations. Alright, so you always need to keep in mind that how much gas each of your operations are actually going to consume. And as you have noticed that we are actually storing this new request inside of storage. So in future, if in some other function you want to access that specific request value, you can actually do that. Alright. And if there was memory in place of storage right here, you won't be able to access it after this function execution had completed. Alright, but as we have defined it as storage, so it's actually going to store it for us inside the contract. So we can actually call it between function calls. Alright, so that is if we actually create a new function and actually grab that specific request from storage, we would actually be able to access that specific request. So now that we have added a functionality of creating a new request, so let's go ahead and add a new functionality so that our approvers in the campaign can actually go ahead and approve that specific request. Alright, so I've defined a new function just below our function create request. Alright, and this function is called approve request. Alright, and it's going to take in a parameter as index. Alright, so which specific request index inside the requests array are we actually going to target so that that approver can approve it? Alright, and this actually is going to be public so that everyone is able to access it, and this is actually going to depend whether or not the campaign is active or not. Alright, so we are actually going to add a modifier active campaign. And now as you can see, we are actually grabbing our request from storage. Alright, so first of all, when we were creating it, we are actually storing the request inside our storage. And in our approve, we are actually grabbing the request from the storage. So we are actually saying our data type request, defining a new variable for it. So we actually need to define a new variable while grabbing it from the array. Alright, so and this is also going to be set as storage. So this is going to actually say that we are actually making a new variable but give the value from the storage. Alright, so from requests array, we are actually going to grab the index that was given us as a parameter of the function so that we know that which index, that is which request our approver wants to approve. Alright, and this is actually going to get grabbed from the storage and get stored in a new variable called request. Alright, so it's going to grab the specific request from storage inside a new variable as request. And obviously, as in the requests array, the data type is request. So we also need to define this new variable as request data type. So once we have our previously created request grabbed into a new variable, we are actually going to add some require statements. Alright, so whether or not the function caller is actually an approver or not. Alright, so whoever actually called this function is actually going to be set as message.sender. And we are actually going to check whether this guy is actually an approver in the campaign or not. Because we don't want anybody who is not an approver also be able to approve a specific request. And then also we are going to check whether or not this request has been previously approved by this address or not. That is the message.sender. So we might come across a situation where our approver has already approved a request but has again pressed the approved button, alright, or somehow called the approve function again. So we don't want this to be an open loophole inside our contract. Alright, so we are actually going to check whether the approver has already approved this request or not. Alright, so if he has already approved it, we are just simply going to return from the function. But if he has not approved it, then we are going to allow him to approve this request. And then we are going to handle the request.approvals. Alright, so this was a mapping that we created inside the struct. And this is going to attach a boolean value to a specific request. Alright, so this is going to be true for all the ones who have already approved this request. Alright, so we have to set this true for this new address. So we are going to set .approvals message.sender is equals to true. Alright, so that means that this address has now approved this request. And then obviously we are also going to increment the approval count. So request.approval count plus plus. Alright, so this actually wraps up our approve request function where a specific approver can actually go ahead and approve a specific request in our campaign. Alright, so now that we are able to create a request and also approve it, now let's go ahead and add the last and final functionality to finalize a specific request. Alright, so now I've created a new function named as finalize request, and this is actually going to be quite similar to approve request. So it's going to take in a similar argument index, which is going to be the index of the request that we want to finalize. It's going to be public, and this one is actually going to be restricted because only the manager of the campaign should be able to finalize one specific request. All right. And this would also be dependent whether or not the campaign is active or not. All right. So we are actually going to add in the modifier active campaign. And then similarly, we are going to grab the specific request index from storage and store it in a new variable request. And then we are obviously going to add some require statements. First of all, we need to check whether or not the approval count is actually greater than 50% of the total approver count in our campaign. So we are actually going to check request.approval count greater than approvers count divided by 2. Alright, so this would actually check whether or not the approvals count for the specific request is actually greater than 50% of the approvers in the campaign. Alright, so once we are happy with the majority, we also want to check whether or not this request has already been finalized or not. Alright, so it may happen that our manager could actually finalize the request twice. Alright, so he might also finalize a request that's already been finalized. So we don't want him to pay unnecessary gas fees for a simple mistake by clicking a button twice. Alright, so we are actually going to simply return him from the function if he has already finalized this specific request. Alright, so as you guys can remember that we actually defined a recipient for a specific request. That is, once the request gets finalized, all the amount that was defined, that is the value that was defined in the request, would actually get transferred to the recipient address. So we are actually going to handle that in here. So we are actually going to write request.recipient.transfer. Transfer is actually a Solidity function which you can chain over an address. And our recipient over here is actually an address. So request.recipient.transfer, and we are actually going to transfer the request.value. Alright, and this value would actually be taken from the contract balance. Alright, so basically the contract is actually transferring money to the specific recipient. And once the transaction is completed, we are actually going to set this request as completed. So we are actually going to set request.complete is equals to true. Alright, so now this actually wraps up our final functionality, that is finalize request. Alright, so now we have actually covered all the functionality that is needed for you to actually build your own crowdfunding application. So obviously this is a Solidity course and not a React course. Alright, so I won't be going through all the front end details, but I would actually be going through all the Ethers.js details. Alright. And we actually won't be creating this high-end front end for this application. All right. So we are actually going to create a small application and actually going to grab all the data using Ethers.js. All right. So we are actually going to deploy this contract onto the Sepolia test network, and using Ethers.js, we are actually going to connect it to a node application. All right. And then actually run a simple React application where we can display all the data that we are grabbing from our own contract. So I would actually be showing you how to call each and every function that we created in our contract, and how to call them and how to grab each and every data, and when you would need one specific data to display. I mean, if I take you through my own crowdfunding application, so I mean, in this home page, the use effect is actually currently grabbing only the data from a specific campaign. All right, that is the get summary function is getting called. Alright, and some other API calls are also getting chained with it. Alright, because we are actually not receiving everything in the get summary. Alright, as I've told you before. And we are actually also not calling requests until and unless we actually click view withdrawal requests. So once you actually click view withdrawal request, that's when all the API gets called for the requests. Alright, so you can actually see it loading, and it takes some time to get the data from the blockchain, and once it gets all the requests, the requests get displayed. All right. So once we are in the home page, we actually don't grab any of the requests. All right. So once we click on the specific campaign, we actually set a specific campaign index. All right. And from that index, we actually specifically call the request of that specific campaign. All right. But you would actually be thinking that, hold on. I mean, we actually created the contract for only one specific campaign. But the crowdfunding application actually has multiple campaigns. So how are we actually going to handle that? I mean, are we going to deploy that contract for each and every campaign? Yes, but not manually. All right. So in the next video, we are actually going to create a new contract. All right, which is going to be responsible to deploy this contract campaign. And yes, you guessed it right, you can use contracts to deploy another contracts. All right, so this we'll be doing in the next video, and until then, keep chilling at the CodeCove.